The purpose of this section is to provide the underpinning knowledge and skills to identify the different states of a refrigerant within a vapor compression cycle and how a refrigerant will absorb and reject heat. These states are saturated temperature, saturated liquid, saturated vapor, superheated vapor, and subcooled liquid. The saturated temperature is the temperature at which a liquid will boil or a vapor will condense. It is the point at which a change of state will occur for a liquid or vapor. In its saturated state, the refrigerant has a relationship between pressure and temperature. The saturated temperature is the point where latent heat occurs. A saturated liquid is a liquid at its boiling point, and the addition of any heat will cause the liquid to change state into a vapor. This is called the latent heat of vaporization. The liquid absorbs heat, causing it to change state into a vapor. A saturated vapor is a vapor at its condensing point. If any heat is removed, it will cause the vapor to change state into a liquid. This is called the latent heat of condensation. A vapor can only be saturated when it is in contact with its liquid. Heat is removed from the vapor and causes the vapor to condense into a liquid. Both saturated vapor and saturated liquid are present in the evaporator and the condenser. Liquid refrigerant enters the evaporator and changes state from a liquid to a vapor. This change occurs due to the warm air flowing over the coil and the refrigerant absorbing this heat, causing the liquid refrigerant to evaporate to a vapor. Vapor refrigerant enters the condenser and changes state from a vapor to a liquid. This change occurs due to the ambient air flowing over the coil and removing the heat from the refrigerant, causing the vapor refrigerant to condense to a liquid. A vapor at any temperature above its saturation temperature is a superheated vapor. A scroll compressor compresses the vapor refrigerant. Charles' law shows that if you increase the pressure, you increase the temperature. The scroll compressor increases the temperature of the refrigerant to a point where it becomes superheated. A superheated vapor is produced if any additional heat or pressure is added to a saturated vapor. If, after vaporization, a vapor is heated so that its temperature is raised above that of the vaporizing liquid, the vapor is said to be superheated. A rising temperature sees no change in state. In order to superheat a vapor, it is necessary to separate the vapor from the vaporizing liquid. As long as the vapor remains in contact with the liquid, it will be saturated. This is because any heat added to a liquid-vapor mixture will result in latent heat vaporizing more liquid and no superheating will occur. When the refrigerant is both a liquid and a vapor, it cannot be a superheated vapor. The refrigerant will have to be a complete vapor for superheating to occur. Before a superheated vapor can be condensed back to a liquid, the vapor must be desuperheated. That is, the vapor must first be cooled to its saturation temperature. Heat removed from a superheated vapor will cause the temperature of the vapor to decrease until the saturation temperature is reached. Refrigerant is usually desuperheated within the system by the air flowing over the coils and removing heat. At this point, any further removal of heat will cause a portion of the vapor to condense to a liquid. The superheated vapor refrigerant enters the condenser and heat is removed to reduce it to its saturated temperature. At the end of the condenser, the refrigerant has condensed to a saturated liquid. The saturated liquid refrigerant, which has been cooled by the ambient air flowing over the coils, will continue to reduce in temperature below its saturation temperature. As more heat is removed by air flowing over the coils, it becomes subcooled. A fall in temperature, sensible heat, sees no change in state. This subcooled liquid has had enough heat removed due to the air being pulled over the condenser that it is now all liquid. A saturated liquid occurs in the condenser about 90% of the way through the coil, changing the vapor refrigerant into liquid. In an operational system, subcooled liquid is present in the end of the condenser piping and in the liquid line. When a refrigerant is saturated, both liquid and vapor can exist simultaneously. When they do, both liquid and vapor will have the same saturation temperature. Saturation mainly occurs in the evaporator or condenser.